Good afternoon, ladies and gentlemen. We're back with an electronics tutorial, and to prepare you guys how to use the instruments. Our first instrument looking at here today is the digital multimeter, and we have seen how it measures voltage and current. Today we would like to play around with a bit of resistance. Resistance is futile. The resistor, and I'm going to hold it up for you to see, and then voila, there's a resistor. The color coding tells us what's the value. The value of the resistor, red, violet, red in this case, with a gold band at the end. Put it down for a moment. So what we do with the resistor is we can use a multimeter to actually measure the value. To do that, we usually have a scale of resistance that we can look at, starting from the largest scale to the smallest scale. The beauty of this instrument is that I can select at what resistance do we need to measure. Alright, so from this color code, we do not know what is the value unless you know your color codes. How does that work? Alright, let's try again. Okay. On the color codes, we have this very general graph that is being shown in many textbooks, and it shows us very nicely the 4-band layout of a resistor. The first band shows us our values that we're going to put in here. It's a color, second band, third band, and a multiplier. The resistor that we showed you guys has got red, and the beauty of computers these days, I can select. It's got violet, and it's got red again, which is my multiplier, and a gold, which is my tolerance. That makes this resistor values 2.7 kilo ohms. 2.7 kilo ohms according to the color code. Can we confirm it? So we expect a value bigger than 2 kilo ohms, thus 20 kilo ohms should be a reasonable scale to use. Now when we measure resistance, there are different ways. Be careful that your fingers do not become part of the measurement. If I do this, the multimeter indicates that my body resistance from my left hand to my right hand is almost 12 mega ohms. Which means I am conducting a very small amount of current between the two probes. But nonetheless, I am a resistor. So my skin resistance is there. So if I now wet my skin, I can actually reduce the skin resistance. So on a hot day when we are sweaty, your resistance is more affected by your body than what you might think. So what we do is, we take the resistor. The best way is to put it in a breadboard, which is one of our other tutorials. And now with the resistor installed, I can simply put my multimeter there, and it will show me the resistance. I am now on 20 mega ohms, too big. We expected something bigger than 2.7 kilo ohms. And there it is, 2.67 kilo ohms. Remember, there's a gold band at the back. That is our tolerance. It means our value that we're looking for is 5% or no more than 5% bigger or smaller than the expected 2.7 kilo ohms. And that is quite within limits. So that's how you measure a resistor. One, you look at the color codes. There is a new resistor, new color coding. If I zoom in, gray, red, orange with a gold band. Then, if we look at our calculator or on the table, thus it was gray, it was red, and it was orange. So we look for orange, and that does the calculation for me. We're expecting 82 kilo ohms with 5% tolerance. Remember, we're using 4-band resistors here, and it makes our lives very easy. So, if we want to measure it, we're expecting something close to 82 kilo ohms. And I install it in a nice place where I can use it. I zoom in so that you guys can see a little bit better. Like this. Voila. So we have the resistor there. Make sure you have a connection. And what do we see? Oh, the multimeter does not show us a value. Why? Look at this. 20 kilo ohms is smaller than 82 kilo ohms. So just put it onto the next scale, and there we go. 80.9 kilo ohms. And that is very close to the expected 82 kilo ohms. The difference between a 4-band and a 5-band resistor is the accuracy, because now I have a resistor component that is much better tolerance than 5%. But more about that in advanced classes. Thank you very much.